the gradient of the tangent has a limit. So we cannot just stop by finding out the gradient when we are doing differentiation, because the gradient is all about the tangent. So if you have a straight line, then y2 minus y1 by x2 minus x1 if you take 2 points. But what about the curve? In order to find out the differentiation, you have to find out the tangent first, and tangent tan theta, that is the y2 minus y1 by x2 minus x1 of the tangent. How to find that? Tangent touches only at one point, remember. So we cannot have a 2 point. For that we have to do what? We have to find, say, the tangent or the differentiation at point A. So we will, try to find out another point B which is very close to it. So we have a A point, we have a B point. So we have in order to make a straight line, we need 2 points. So by these 2 points, we can make a line. But what we'll do, we'll try to merge A and B. We will try to bring A and B so close that they will become 1 point. Now we are getting the tangent. So making a tangent on this A and B which are coinciding, that can solve our purpose of finding out the slope, for finding out the y2 minus y1, finding out the differentiation. I hope you got the idea. This is a chord, this is not a tangent, but in order to find out the gradient of a curve, we need a tangent. For that tangent, we take 2 points, try to merge them. So that small difference where B will be there from A is called del x. We'll call it as del x or del y. Very small change. It is equal to 0, not 0, it is equal to 0. Okay? That will give you the instantaneous value of the rate of change of one value with respect to another on that point. That is the tangent. So what we'll do is, we'll move A and B closer until they become 1. Once they become 1, we can find out the gradient. So the gradient of the chord is simply change in y by change in x. So it will be any straight line. But now the A and B are so close, very close, that the distance between them, these 2 points are very small. Del x, del y. Del x and del y. So del x is simply y2 minus y1, x2 minus x1. But we can call y2 minus y1 as delta y because the distance is very small. It is equivalent to 0. Now this is 0. I am saying that this is equivalent to 0, not 0. So A and B has coincided. So A and B are coincided. Now you will say, oh, delta y will be 0, delta x will be 0. It will be a form of 0 by 0. That is not acceptable to us. It is undefined. What to do then? For that we need limit. That is why we need limit in differentiation. So the del x tends to 0. When we want to find out the value of y changing with x, we will take that del x tends to 0. It will not be 0. Otherwise, we'll get a value of 0 by 0 or something by 0, which is incomprehensible. So del x is so small. It is so infinitesimal. It is not equal to 0, but it is almost 0.